All right, friends and neighbors, welcome back to another networking video. Now, I have gotten a lot of questions about IPERF, TCP, UDP, window size, and then some more stuff on operations. So I thought what I would do this time is we'll start a series. I have no idea how much time we'll spend on it, but we're going to put all of these things together and we'll link them together through a series of videos. And today I'll just talk until maybe the video gets a little bit long. So we're going to do TCP, UDP, and IPERF from the bottom to the top. And we'll start with a couple of actual connections that I'm going to do right here, and then we'll keep those going for the next ones. So no real clear guidelines and very few slides for this one. So what are we starting with as a basis? Well, the TCP handshake is where we're going to start. We'll do UDP another time, but we're going to do TCP because that's the complicated one. And the handshake is the key, right? The SYN, ACK exchange at the beginning of the TCP connection. And so what's happening in that handshake? Well, we've got sequence numbers and acknowledgement numbers that we're going to establish. Each side has sequence numbers. Each side has acknowledgement numbers. Now, the acknowledgement numbers reference the sequence numbers from the other side. We're also going to negotiate window size at this point, and then we're going to decide what options we're going to use for this connection. Now, a good question at this point is, what are the default values that we're going to use? Now, we don't know until we actually look. If you're on the development side of things, you can set the window size and the behavior of the TCP stack for that application, but we're just going to see what happens. And then another question is, do things change over the course of the connection? And what we find out is that they often do. Now, on the question of changing window size, there's two things that we have to worry about. One is, did the overall window size that we're using for the connection change? And it turns out that can change. But what are the window values that you see in packet capture? Well, that is entirely based on the initial window size that you sent and what we call the bits or the bytes in flight. So TCP has an algorithm that measures that. And then how does IPERF figure in? Well, we're using IPERF to measure, network conditions and quality of the condition and what we can get for throughput and all of that stuff. And then we can use IPERF to determine maybe how the behavior is going to change given some set of characteristics that we want to look at. And of course, another big one that we have to look at is the network conditions. And a huge factor in that is wired versus wireless. Okay, so that's our starting point. So without further ado, let's take a look at a network capture that we're going to start with. We're just going to go to a web browser, okay? So I have Wireshark going, and clearly there's some things happening here. These are not things that we care about. But I'm going to now do a pair of connections to the same destination, and we'll do some compare and contrast right there as well. So here is Firefox. I'm just going to open up two tabs and go to YouTube with the same thing. So here's a YouTube tile. So there's that. Probably get some Mr. Beast stuff. There we go. Saturday Night Live. And this is just, whatever the algorithm thinks that a blank browser is supposed to see, right? I'm not signed in. And we have some commonality between the tiles, but that's not really the important thing. What we're really interested in is that we got two things going to the same destination. Okay, so I don't care about that right now. So now that we're done with that, I'm going to close this. And here we're back to Wireshark. Now at this point, we'll just stop the capture. And we'll take a look at the TCP connections that might be out there. Now, since I just started these connections, what we're curious about is the behavior for those particular connections. And maybe what we'll do is the start of all this is actually a DNS request that goes out. So here's a look at the name service queries that I made. Now, I suppose we ought to cover just a little bit of ground to understand what we're looking at here. Now you can see that this is I've got a filter on for DNS. I started at 290 because the minute you open up a browser, it does a lot of stuff. And then you make a query, and then the browser does what you're after. So there's a whole bunch of queries that went on first. And then we can see here that I start looking at Google. All right, so before we jump into this, let's cover a couple of ideas about DNS. Now, if you're trying to recreate what I'm doing here, the way that you would have to do it is you would have to turn off secure DNS. And what that means is that your DNS is going to use your local resolver, your ISP or wherever you point yourself at for a name server. So I turned mine off. If you don't turn it off, what you see is that everything goes out to Cloudflare and Mozilla. We also have to remember that Google owns YouTube. And so we're not actually looking for YouTube queries, although we can tie them together if we're a little clever about how we do that. And so what we want to see is that the IP addresses that we're actually using on the net, on our conversation, actually tie to the queries that we were made. And one handy tool that we're going to use for that is NSLookup. So let's take a look at that. So here is NSLookup. I just did, actually maybe we'll do that from the start, right? So if I do NSLookup, and then I just say, hey, tell me about YouTube. I get a couple of IPv6 and I get a couple of IPv4 answers. But the key that we care about is it's 172.17.13 something, right? So there's a bunch of them. And so that's what I'm after. So if in my packet captures, I can see these IP addresses or at least 172.217, then I'm happy. Okay, so that's NSLookup, and that's what we're looking for. So let's go back to DNS. So here is DNS. We can see that I was making these queries. So this is a conversation that's back and forth between my gateway, because that's where I'm sending all my queries to. But it's not resolving the queries themselves. It makes a request for me and then gets the answer back. So here we've got a bunch that are Google. And hey, look right there, 172.217.13. So let's get one from me. And we'll take a look at how that appears, right? So when you make a query, it's an actual query that you make. Tell me a little bit about the IP address that might go with this. And then an answer comes back. So here's the original query, and then here's the answer that comes back. And hey, there's that 172.217.13. So now we've sort of satisfied ourselves that these DNS queries are going out to actually YouTube, and these are actually tied together. Okay, so that pretty much finishes us off for DNS. But that's the very first thing that you do with every single conversation that you have out there. And that's a way that you can look at what's actually being used on your network. Okay, or in your conversation. So let's go back to TCP. And I'm after a couple things. So I'm going to say TCP, and I'm going to say ampersand IP.source equals, and then I'm going to do my IP address. And the reason that I want to do my IP address is because I want to get a sense for where I am in the conversations, at least for the startup. So these are all of the IP addresses that we use. Remember that the DNS query for Google happened around 290. So maybe I can take a look there. I can start there and look for TCP conversations that might start up. A lot of what we do on the web is going to be HTTPS, but for this part, we don't actually care because we have to establish the connections. We're also looking to see if I'm talking to actual Google. Now, a lot of this stuff, as you can see, we're using TLS, so that's the encrypted part. But what we're looking for is maybe a SYN flag. Hey, that looks like it right there. But that's to a different IP address. This is a SYN at 256. I like that. So that maybe is where we'll start, right? It's amazing how much traffic you can generate. Okay, so that's probably a pretty good start. Okay. So here is my original SYN flag set. So this is a handshake that I'm establishing with YouTube, or at least with this IP address. Whether it's a load balancer, it doesn't really matter. But here is the first part of the handshake. And I'm talking to 172.217.13, and we've established that that is the destination. Now here is the answer that comes back from 214. We got to sort of ignore this one in between. This is an acknowledgement from me to somebody else. Okay, here is the SYN ACK. So remember, when in a client-server connection, you send out a TCP packet with a SYN flag set, and then you get a SYN ACK from the server, and then you send an ACK back in the direction. This is the handshake. This is the part that we care about, at least for this particular video. All right, now let's take a look inside and see what's happening. Now there's a lot going on here. What I'm going to do with this particular video is, in addition to what we're talking about, I'm going to include in the show notes all of the links for all of these things. So if you want to spend more time on it, you can, but that's what we'll do. So I'll include all of the information that we've done previously on this. So if you want to dive into any one particular thing, or if I don't cover it to your satisfaction, then you can go back and look at some of the other videos. All right. So here is our TCP connection starting up in the client side. So there's me. And here is the source and destination IP addresses. Now this is 443, that's secure, but you still start that up with a TCP connection. And so we're not encrypting it at this point, because whether you're doing HTTP or HTTPS, it's still wrapped up in TCP. So here's our flag, and here is our window size. So we've got 4 things that we want to look at: sequence number, acknowledgement number, our window, and then options that we're going to be using. So there's 2 sequence numbers here. We know that these are relative and raw numbers. Well, what does that mean? If I look at the hexadecimal and I take a look at the sequence number, 4B, so I'm looking down here in the bottom, 4B, 7F, 64, 61. That is hexadecimal version of the sequence number. Here is the sequence number in base 10, and here is the relative sequence number. So what Wireshark does is starts counting at 0 for you. It makes it a lot easier to follow. The acknowledgement number, oh, it's all zeros. Why is it all zeros? Well, I haven't heard from the other side yet. Remember that the acknowledgement number is 1 more than the last sequence number from the other side. In other words, what you expect from the other side. Well, I haven't gotten anything yet, so we're going to set this to 0 to start off with. Here's our flags. We don't care. We know that that's supposed to be a SYN flag. Okay. Now we go down to the window size. Now this window size, if we take it at face value, is set at 64,000 bytes, which is nearly the maximum for this 2-byte field. All Fs would be the maximum value for this particular field. So maybe what the client is saying, my machine here is saying, is that go ahead, use the biggest window that you want. This is my receive window. This is how much data I'm willing to accept. Now in the options, this is me saying these are the options that I would like to use for this particular TCP-based connection. Now it's what I want to use. It's not necessarily what we are going to use. Now we can see we've got a lot of options here. So there's 2 things, right? One is that the normal TCP header is 20 bytes, and then we expanded it by 4 bytes for each one of these options. Now a couple of these are included in the original RFC for TCP, which is, so that, for example, the maximum segment size, that's part of it. And so it's 1460. Why is it 1460? Because 1500 Ethernet minus 20 for the IP header minus 20 for the TCP header. But we've got an additional one here that says, hey, I am willing to scale up my window by a factor of 256. So my window size is not actually 64,000. It's 64,000 times 256. So that's an enormous window size, which is essentially me saying, I will take whatever data you want to throw my way. So those are the 4 things we want to look at in the connection. Now let's see what the server has to say. The server says, here's my sequence number. Notice that the 2 sequence numbers have nothing to do with each other. And here is the raw and relative numbers, and then we saw the hexadecimal. Now the acknowledgement number. The sequence number that I used was 0 relative, but you recognize maybe this from the previous, right? So here's 62. What was mine? My sequence number. Oh, 61. 4B7F 64 61. So that was the sequence number I'm using. What the server is saying is that I acknowledge your sequence number that you sent me. The next one that I expect from you is the next byte, 62. Okay. So we've got two sets of sequence numbers, and the acknowledgement number just references the other side's sequence number. Here's the window size here. Oh, look at that. That is a maximum window size. So that is to say that the server is willing to have a very large window, very large receive window. What options are we involved in here? Well, we can see that we've got a similar stack of options and that the server says, yeah, I agree. Let's go ahead and use this set of options, or at least this is the set of options that I want to use. And then the client comes back, me, and says, I acknowledge that. Now, there's not a whole lot happening here. This is just my turn to say, I acknowledge what you sent me. So the server says, SYN-ACK. I am willing to establish a connection, the SYN, right? We're going to synchronize our two sides, and then I'm acknowledging what you sent me. When I come back, I just say, I'm going to acknowledge what you sent me. So that is the beginning of the connection for that tab. Now let's take a look at one other thing while we're here. This side is using 2758. So we're going to 443, and we are using a client port of 20,758. So any of these packets that we see coming here should be using these two ports to communicate. And that's how my machine keeps track of this particular tab, right? But I know that I opened up another tab, and I did it pretty quick, so I shouldn't have to look very far. Let's see if we can find it real quick. All right, so this looks like another conversation here, so maybe starting about 494. And so we want to see the entire thing. So this looks kind of like another conversation, maybe the other tab. And we see again, we've got a SYN, and who am I looking to communicate with? Right here, let's see, there's the SYN-ACK down there. So here's a SYN. We're really interested in here is what's going on with the port. Okay, so another TCP connection starting up there. We have a different port number, 20,762, and similar window size from my side, similar set of options. Let's look at the SYN-ACK. So there's the other port, right? Now this is coming back to me. SYN-ACK. Oh, let's see, relative and sequence numbers, right? We know this is part of the startup, that large window size, and the similar set of options. But the important part for this thing is that we've got that port number. Okay, so the only real reason that we did two connections here, two tabs, is that we wanted to verify a couple things. One is that we can separate the two tab conversations. I could watch two different videos in the same tab, and the machines keep it straight. And the way that they keep it straight is because of the port number that I'm generating locally. So it might be the same source and destination IP address. It might mean the same destination port, but the thing that differentiates them is that fourth number, the source port on the client. So that's how it knows to communicate back to me on this port. And then, of course, we've got two different connections to the same destination, so it sort of makes sense that we have the same options and the same starting window sizes. Well, let's take a look at one thing. I just realized we're getting quite long here in the video. Let's look at one thing. We're just going to scroll down, and I'm going to say, we'll just look at my side of the conversation. And so as I go through the conversation, right, here is me, and maybe what we'll do is we'll also pick, and we'll do an IP destination, and we'll pick 13206. So this is just this conversation now. So what I'm after now, we're not going to get the back and forth. We're just going to get sort of one direction. And we'll see what's happening with the window size. So I'm going to focus on that here. So that'll be this field right here that we're interested in. So remember that when we got the SYN flag, right, we started here. This is the beginning of the conversation. So let's see what's going on. The very next packet that you see from me, it's 612. Now remember that at this point, I've made a query to YouTube and YouTube sent me all kinds of stuff, but I'm also trying to acknowledge it. That's why we have the ACK flags. So we see that this is actually quite small now. At this part of it, all that we're doing is we're setting up the TLS part of the conversation. We're not actually into data at this point. So very, very small. You can see that all of this right here is we're negotiating the TLS connection. So this also means that it's very strange that it's 512, right? We go, why is that happening? Well, that has everything to do with how they wrote the code for how we're going to establish the connection with the server. And then I close the window. Okay. So from this part of the process, all that we can really see is that we had two changing window sizes. So for the same connection with the same destination, I had two different window sizes that I was using. Now, we didn't actually do TCP data a whole lot here, so we didn't get to see the expanding and collapsing part of the window. We'll take a look at that at another time. We also saw that the two sides don't have to use the same window size. Now we can see some variation here, 512 down to, the 265 and the 497 down to 265. And so what's happening there is that they're setting the small window size for the TLS conversation, probably to control what's sent back and forth via TLS. And as a chunk of data goes, the window size actually shrinks, right? So there we go. Now, I suppose it's worth noting that right there's the beginning of the termination of the connection, right? This is me closing the tab. So the teardown handshake is the FINAC from both sides. And so we're looking for the clearing of the buffer, and there is the FINAC from, let's see, there's me shutting down the connections, and there's the other side shutting down the connections. So that is the termination of the handshake. Okay, we see the handshake, we see the source and destination ports, we see the options, we see the sequence and acknowledgement numbers, and we see that from both sides of the conversation. And then if we go through it, we can see that the window size can vary a little bit. The two sides are not tied to each other. And then we see the FINAC to terminate the connection. All right, so this wasn't really a lot of TCP data. We'll have that next time. But this is just, hey, let's get started. We're at the ground floor right now, and we're working our way up to the top. So TCP, UDP, IPERF on the first floor, even though the guy on the graphic looks like he's on the third floor. The variables can change over the course of the connection. We will actually try to demo that later on. And then when you're using IPERF to test all of this stuff, you have some direct control over some of these variables. All right, like and subscribe if you're jazzed about the series that we're going to do here, and I will see you in the next one. And whether you're using HTTP, HTTPS, big windows or small windows, may those packets always reach their destinations.